going tonight?
Alright, let me pull it up really quick.
Okay.
Alright, so we're graphing quadratics, and yeah. Alright, so the first one is y equals parentheses x plus 2 parentheses squared minus 3.
All right. There are a couple of formats for quadratics, general formats. Okay. Probably the one you're most familiar with is this one. This is called Vertex Format.
Mm-hmm.
You familiar with that?
Yep.
Well, this is very close to that, right?
Yeah.
So what's A?
A would be
1.
yeah, 1.
What's H?
H would be the plus 2.
Well, it says X minus H. So what does H have?
Minus 2?
Yeah. In other words, if it's minus 2, then X minus a minus 2 would come out to be X plus 2, which is what we're looking at. What's K?
Right. K would be plus 3.
Minus 3. It's a plus K.
Oh, yeah.
Okay. So if it says plus K, then that's K.
Right.
Now, what is H and K? Why is this called Vertex Format?
Are they the...
That's the X and the Y coordinate of the vertex. So this is the X coordinate, and this is the Y coordinate of the vertex.
Okay.
And that's important because whenever you go to graph a quadratic, the most important point on there is the vertex. You know what a quadratic looks like. It looks like a parabola, right?
Right.
Well, the vertex is the end of that parabola. So where is this vertex?
Wait, can you repeat it?
Where is the vertex of this parabola that they want you to graph?
It would be...
We'll find it on the graph and we'll label it, and then we'll go from there.
I'm confused. Wait, so...
H is the X coordinate of the vertex. K
Right.
is the Y coordinate of the vertex. So where's this vertex?
-2, -3?
Uh-huh. So I'm going to call that -2. We'll call this -3. So I know that right there is the vertex. Now, what else do I know about this? Does it open up or does it open down?
It would open down.
Whenever
Or up.
A is
Up,
positive, it opens up. When A is negative, it opens down. So this is going to open up. So it's going to look something like that. Something. Not exactly like that. In other words, in order to properly graph a parabola, quadratic, you have to have 3 points. And
Right.
at the moment, we only have 1 point, this vertex, which is at -2, -3. So we need 2 more points. And this is always a little bit the tricky part. I kind of consider it the easy way to do it and then the hard way to do it. The hard way to do it is where you find those 2 points, the x-intercepts.
Right.
The reason that's hard is because what is y equal to when you're solving for x-intercepts? Always.
0.
Okay, so let's try solving for that. 0 equals x plus 2 squared minus 3. You with me?
Mm-hmm.
Going to take the 3 over to the other side. Now how do I solve from there?
So you would do, so you'd,
I got 3 equal to the quantity x plus 2 squared.
right.
How do I solve for x? Because whatever I get for x are going to be these 2 points. And then I'll have every point I need on my parabola and I'll be done with the problem.
Okay.
So you got to know how to solve that equation. When something's being squared, how do I get rid of the squared? In other words, I've got to end up with x equals something. So I got to get rid of the squaring and I got to get rid of the plus 2. Which one do I get rid of first?
The squaring.
Okay, how do I get rid of it?
X plus 2, x plus 2.
Well, how about we take the square root of both sides?
Okay.
When you take the square root of something being squared, you get that something.
Right.
Well, because I took the square root of the right side, I got to take the square root of the left side. More importantly, because I'm taking the square root of both sides, my answer is going to be plus or minus square root of 3. Now keep going, solve for x.
It would be, oh my god, I'm freezing up. Alright, so,
How do you get, when you're trying to solve for x, what's with x that you got to get rid of?
plus 2, or,
How do you get rid of
plus 2. Minus 2.
Minus 2 to both sides. Always keep that thought. You cannot do anything to one side of an equation. You screw it up if you do something to one side and you don't do it to the other side. But you can always do the same thing to both sides. So you're right. I'm going to take plus or minus root 3. I'm going to subtract the 2. And that are my 2 answers.
Right.
Now, how does that translate? Well, that point there is clearly the negative answer. What's the y coordinate?
It would be 0, -3, right?
Oh, you got it. 0. The y coordinate is 0.
Or is, yeah, 0.
Not 0, 0. The x coordinate is negative root 3 minus 2. Now, if I have to put that in decimal form, which I hate, but if I have to put it in decimal point, root 3 is about 1.7. So it's minus 1.7 minus 2. So that point is about 3.7 comma 0. And the reason I say I hate to do that is because that's an approximation. the way I originally wrote it, minus root 3 minus 2 is the x-coordinate. That's exact.
All right.
Okay? Now, that's the left x-intercept. We did get two answers. So what's this answer over here, the right one?
Oh my God. So it'd be, can you repeat it?
What's this one? In other words, here's our x-intercepts down there. Plus or minus root 3 minus 2.
Right.
I know the left one is going to be the negative, because that's going to be a bigger negative value. I can see from my drawing that this right intercept is going to be a higher number than the left intercept, right?
Right.
So it's the plus root 3. So I would write that as plus root 3 minus 2, comma 0. And if I had to absolutely give you a number, that is going to be minus 0.31, comma 0. So my drawing wasn't far off. It was relatively close. It's just this x-intercept should be to the left of the y-axis. So a more accurate drawing might be this.
All right.
Okay? So when they ask you to graph a quadratic, you've got to find the vertex, and then you got to find two other points. Now, a lot depends on how they give you the original equation. It's fine if they give it to you in vertex format like they did. That's the easiest one. That's the easiest one to solve. In terms of what's the most difficult format to graph, this is the easiest format to graph, because they start you right off with the two most important numbers, the x and y coordinate for the vertex.
Right.
They could have given you an equation like, if I expand this, I get x squared plus 4x plus 1. That's the same equation. But now it's not in such a pretty format for graphing it. First of all, I don't know how to find the vertex. I could complete the square, put it back into vertex format. That'd be one way to do it. Or there's a very important formula that you need to know. The vertex x coordinate equals minus b over 2a. Have you had that?
Oh, yeah.
If they give you the quadratic in standard format, like my blue, that's standard format. That's not vertex format. I can still figure out the x coordinate of the vertex. Notice that minus b would be minus 4 over 2 times 1. So the x coordinate should be minus 2. Is that what I got first time? Yes. And now to figure out the y coordinate, you plug in minus 2 into that equation and you calculate what y is. So whether they give you the original quadratic in vertex format or standard format, you can always calculate the vertex, and that is always pretty much the first step. There is one other format, and I'm going to write it just to see whether you've had it or not, and that is this format. This is called X-Intercept Format. It's A, x minus p times x minus q, where p and q are the x-intercepts.
Mm-hmm.
So there's three main formats. There's vertex format, there's standard format, and there's X-Intercept Format. Each one of them needs to be treated differently. X-Intercept Format actually might, I don't know if it's the easiest one. They're all equally about the same in terms of graphing them. Okay? If they give it to you in X-Intercept Format, well then P and Q are your X-Intercepts.
Right.
Now I know that it's got to be like that. Now all I got to do is find the vertex and I'm home free. So it kind of depends on the format they give it to you. So let's start with another problem. Got probably one more problem.
Y equals...
You have a 7:30, so I'm going to have to go up then.
Y equals negative parentheses x minus 4 parentheses squared.
That's it?
Yep.
Okay. That's what kind of format?
Standard?
No, standard format.
No, that's vertex.
Okay, good. Vertex format. So tell me where the vertex is. Tell me the x coordinate of the vertex and tell me the y coordinate of the vertex.
Wouldn't it be negative 4, positive 4?
Remember what the standard is. Y equals a times x minus h. It's always minus. It's never plus. Plus k. So if I'm looking at this, translate. What is h?
H is minus 4.
No. If it was minus 4, then I'd be looking at x plus 4. In other words, this says x minus h. This says x minus 4. So what is h?
Positive 4?
Yeah. I can see that. In other words, if the general format says x minus h, and the format you're looking at says x minus a positive number, then that positive number is h. If h were negative, then I have to be looking at an x plus something. And I'm not. I'm looking at x minus 4. So the vertex x coordinate is positive 4. What's the y coordinate?
So the y coordinate, it would be...
You see anything over here?
1, or no, 0.
There you go.
Yeah, 0.
If it's not there, it's 0. In other words, it's a times this plus k. So k has to be 0. Okay? Now, let's graph what we know, which is the vertex, right there. That's going to be at 4, 0. Now, does this open up or down?
This would open up, or down.
Correct. So, something like this. When I say something like that, we know it's a parabola, we know it opens down, and we know where its vertex is. But I still need 2 other points.
Right.
In this particular case, the easiest, in other words, it does not, I don't have 2 x-intercepts. I can see by my graph that I got 1 x-intercept only. So, let's assume that this thing looks more like this. And it crosses that y-axis somewhere. That's actually not a hard point to find. What is x equal to at that point?
4?
What is x equal to whenever you are on the y-axis?
0.
Okay. So plug in 0. into our equation, and you get y equal minus 0 minus 4 squared. So what is that?
Well, that would be...
Look at the graph.
That would be 0 minus 4.
I want an answer. I want a number. I want to know what this y value is. I know the x value is 0, but what's the y value?
Negative 4, right?
Well, first of all, it's negative 4 squared. What's negative 4 squared?
16.
And then you got a negative sign in front of that.
Negative 16.
Okay. And the reason I said look at the graph is because a lot of people might make the mistake and call this positive 16. And yet you can tell from the graph that it's not positive 16. It's got to be negative. It's below, everything is below the x-axis.
Right.
Now, I've only found one other point. But the one thing that I know about parabolas is they are symmetrical about the vertex. So I actually know this point over here also. What does that point over there got to be if it's symmetrical? What's the x-coordinate going to be?
The x-coordinate will be...
Let me erase the red. The red is not supposed to be on there. That was my first attempt to draw it. Because all it's doing is confusing you now. So we know that this parabola is symmetrical about that dotted blue line, right?
Right.
So how far is that dotted blue line from the one point that we know, the y-intercept?
It's 16.
No, it isn't. 16 is the y measurement. How far is this distance right here?
4.
Okay. So if it's 4 units from there to there, and it's got to be how much units from there to there? If
4. So
okay. So they're
8.
both 4. So what's the x-coordinate on this third point?
8.
Okay. What's the y-coordinate?
16?
Negative 16.
Negative 16.
In other words, the y-coordinate's the same. Since it's an up and down parabola, the y-coordinate doesn't change. And now I have my 3 points. And that's all you need. When you're graphing these, you got to find 3 points. In fact, some teachers used to ask for 5 points, which is a little silly because 3 points define a parabola. You don't need, it's like a straight line is defined by 2 points. If I give you 1 point and another point, there's only one straight line that can go through that. So asking somebody to find a third point would be a little silly. Or a fourth point. You don't need anything but 2 points to define a straight line, and for a quadratic or a parabola, you only need 3 points, and we have it. There's 1, there's 2, there's 3. Now, theoretically, we could find we could find this point here, we could find this point down there, and we could find that point there. Those 3 green points also define a parabola, a unique parabola, the same one that we're on. It's just they're harder to calculate. In other words, when you're given it in the vertex format, first of all, vertex is very easy to calculate. You instantly know whether it's going up or down. And calculating the y-intercept is pretty easy because all you do is substitute x for 0, or 0 for x. All right, Blake, I'm going to have to run.
All right.
But
Thank you very much.
I'll talk to you next time.
Yeah, you too. Have a good day.